In this video, I'll show you how to solve the ALEKS problem called Interpreting the Symbol for a Nuclide. In this problem, you'll be given a data table. This data table contains 3 rows. Each row pertains to a different nuclide, which is just a fancy way to say that it's an atom. And there's going to be some information in this table to start with, and you have to fill in the rest of it. So of course, you know the number of protons, you know what that means, and the number of neutrons as well. Then we have these 2 additional symbols, Z and A. Z is a representation of the atomic number, which is just another way of saying the number of protons. So Z is just simply the number of protons in an atom. No matter what somebody might call it, that's all that it is. So for this first row, we know that our nuclide has 27 protons, and that means that Z is 27. A in this table, wouldn't it be nice if that was the number of neutrons? It's not. A is the mass number, and it is the sum of the protons and the neutrons, so the protons plus the neutrons. For this particular one, 27 protons plus 32 neutrons. I am going to do that on my calculator just to make sure. I don't trust myself. That's 59. So A, the sum of the protons plus the neutrons. Now, the one thing we haven't done yet is fill in this box for the nuclide. Notice over here you have this button in ALEKS. So if you click into this box and then you click on the button, it's going to give you this framework in this spot over here. You can start, let's see, I would start by starting with this upper right-hand box. So in this spot, this is where you would write your A number. We just figured out that it is 59, so that's going to go right here in the upper left-hand corner. And then in the lower left-hand corner, this is where we write Z, or the number of protons. And we know for this one, it's 27 right there. Now, the last thing that we have to fill in is the 2-letter symbol of the element. And the 2-letter symbol of the element is based off of the number of protons, or Z. And to solve this, to figure this out, what we're going to do is go to our periodic table and we're going to find element number 27. So if we're looking at these whole numbers, like right now as I'm zooming in on 22, 23, 24, 25, 26, 27. We're not paying attention to the decimal numbers, 58.933. We're just looking at these whole numbers. Number 27, that is cobalt, CO. Make sure you're capitalizing the first letter, lowercase the second letter. Let's look at the second one. This one is SB, that's antimony. Remember that this in the bottom left-hand corner, that's our Z, it's 51. And that is also the number of protons, 51. 121 is our mass number. That is our A. 121 is the mass number. The number 121 is going to be the protons plus the neutrons. So I'm going to go 121 minus 51 is a 70. That's the number of neutrons that I have. And we have one last one down here. This is telling us that we have 42 protons. So 42 protons. And 42 is going to go down in this spot right here. It's telling us that we have a mass number of 98. We can use that to figure out how many neutrons we have. 98 minus 42 is 56, so that's 56 neutrons. 98 goes in the upper left-hand corner. And again, like I know that this is kind of confusing. These 2 numbers together add up to A, the mass number in this particular column for all of these. These 2 numbers add up to A. And then last but not least, we need the identity of the atom. The identity is based on the number of protons, which is 42, which looks like we're counting backwards. 43, 42 is MO.